Hey, fellow mathers. Before we get into this episode, have we got some really important information?
Y'all, registration is now open for our Building Powerful Mathematics online workshops. I know you're as excited as we are because this is where the magic happens. The why, when, how, the details, the experience, making real mathing happen in you and your classroom.
Building your numeracy, your mathematics, gaining insight into which models and strategies to use, seeing the teacher moves in action, and more is all jam-packed into these content-rich online workshops that you can take anytime, any day on your schedule. We've got workshops for teachers kindergarten through grade 12. Head on over to mathisfigureoutable.com/workshops to find your best fit. That's mathisfigureoutable.com/workshops.
Registration is only open for a short time, so book your spot before it's too late. Now on to the episode.
I'm sure the episode's going to be great. Hey, fellow mathers. Welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
We know that algorithms are amazing human achievements, but they're not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
And I'll just pause there for no reason at all.
You know what's horrible? I was like, what's going on? I have a Charlie horse in my foot.
Oh no!
Rubbing it while we're talking. I don't know what happened to me.
So you're thinking, I'm so glad Pam paused because
I thought you were going to stop it.
Dude, eat more potassium. Go get a banana. Are you okay?
Yeah, I'm fine.
All right, we invite you to join us to make math more figure-outable. Are you running these days? I don't even know.
Yeah.
Yeah. All right, Kim, how far do you run? What do you?
Oh no, I'm just running with my entering 8th grader is running cross country, so I wake him up at 7:30 in the summer. Yay, mom! And we just go like 2 miles in the morning.
Just 2 miles. Yeah.
Well, yeah,
just a little short 2 miles. Says the marathon runner. All right.
Okay.
Does he like cross country?
Yeah, he's got some friends that do it, and so he likes it. And I think running's fantastic because it's the kind of thing that you could maybe do in your life. I don't know a lot of people who are going to play football at 45 or, maybe pick up basketball. I don't know, but he enjoys it. And I'm super excited that he enjoys it.
Yeah, yes, you are.
Okay.
All right.
Hey,
podcast. Yes.
I found us another review. It makes me happy.
Nice. Yeah.
This one's title is Life-Changing for Teachers and Kids.
Oh,
I know. And the handle of the name is Stuck in 4th Grade. Oh, that's so sweet. I don't know if you're stuck because you wanted another grade or you never get out of 4th grade because you're amazing and you stay there forever and ever.
Yeah, there you go. I think stuck might be because you're like, I'm here.
That's
like
great.
You're purposely in for. Yeah. Okay.
Well, okay. So it says 30 years ago. So maybe. Yeah. 30 years ago, I hung an 8x2 sign in my first classroom that merely stated think in all capital letters.
Nice.
And then I proceeded to teach my kids to mimic.
That sounds like my classroom.
I know, right? So following this podcast has opened my eyes to the surface level of understanding that I have been chasing all these years. This past year, I have listened to Pam and Kim sometimes 4 times before recreating the same problem string in my classroom. Oh. And my 4th graders have blown me away and literally outperformed me in their developing intuitive sense of numeracy. I'm so grateful for the power this gifts my students and even more grateful that the problem strings can now be purchased in a book. I will continue to listen for the insight and encouragement to teach counter the rote algorithm culture, but can drive safely without jotting things down.
That's unbelievable.
I know. And what's super exciting is the 4th grade problem string book is out for pre-order and will be shipping in the next couple of weeks. So Stuck in 4th grade, I'm so excited that you're going to have that for this school year.
Oh, that is fantastic.
Isn't that fun?
Drive safely without jotting things down because it's in a book now. That's fantastic.
Yeah.
And I also like the counter rote algorithm culture. I like that. Yeah, I like that a lot.
Oh,
And I tell you, stuck in fourth grade, I am right there with you. As soon as I started turning over the thinking to my kids, in not just like in the way that we're suggesting, right? Not just in some random, like I was always trying to get kids to think like you were. I just didn't know what that meant. But
yeah.
as soon as I actually knew what it meant, I am continually blown away by kids. I'm still
Yeah.
thinking about the kids I met in Australia.
Yeah. Real
So
math's
stinking
fun.
cool. Oh, so in fact, Kim, one of the
Yep.
most fun things that I had on that trip when I went to the Blue Mountains with that principal and his kids, at a couple of times I was with either the 7-year-old or golly, how old was the old one? 9 years old, 10. Sorry, don't tell them how I didn't remember how they were. And we just played math games as we were trucking up and down these lots and lots of steps. Oh my gosh, I went up and down. I did more steps that day. Anyway, it was fantastic. But the mathing those kids were doing, it's just I just love it. It's one of my favorite things to do ever. Just
Yeah.
to ask kids questions. Cool.
Very cool.
All right, hey Kim, people ask me sometimes questions that kind of give me the feeling that they think all I do is numbers and numeracy. Like
Hmm.
literally they'll say, why do you only do numeracy? Why do you only do numbers? So I don't. Like I do all of mathematics. I was a high school math teacher. I like geometry. I mean, there's yes, there are lots of different areas of mathematics. Sometimes you might see us just do numbers and do problem strings with numbers because it's a good inroad. It's a good entry point for people to kind
Hmm.
of get on the math is figure outable track. But hey, we thought we'd change things up a little bit. So
Yeah.
Kim,
Yep.
I said, Kim, let's do some geometry. And then I said, you pick. So
Yep.
it is your pick today. What are we going to do?
Okay. So when we were writing, I don't know, can we say, is that what we're doing? Did we already said that a million times?
Go ahead. Yeah,
We
I
were
think
writing.
so.
Okay. So
Yep.
when we were writing for Math Learning Center, the Bridges in Mathematics curriculum, one of the things that we thought long and hard about was making sense of geometry
Mm-hmm.
and the hierarchy of the way shapes fit together,
Mm-hmm.
two-dimensional shapes. And so we wrote some lessons in there. And one of the things that we put in those lessons were these geometry riddles. I don't even know what we called them. They're riddles.
Mm-hmm.
And so I grabbed a couple of those and I'm going to give them to you today. I'm going to
Oh,
give you some
fun.
riddles and you can
Okay.
think out those riddles. They're kind of like clues. I'm going to give you a clue. You're going to tell me what you know about it. Then I'll give you another one until we figure out what shape I'm thinking of.
Nice. All right. I'm excited. Let's do it.
You thinking hard today? It's always
I
me. I always have to think hard out loud.
so this is good turnaround. All right.
Okay, ready?
Bring it on.
Riddle 1.
Okay.
I have 4 sides.
Golly, I think you are a quadrilateral.
Okay.
But I don't know anything else about you. So you're a
No.
polygon with 4
Mhm.
sides. Polygon with
Okay.
4 sides, and we call that a quadrilateral. Okay.
Okay. I have 2 pairs of parallel sides.
So 2 pairs of parallel sides means you're not a trapezoid. Well,
Hmm.
depending on which definition you use, but you are a parallelogram.
Which
You have
means I'm
2 pairs.
also a quadrilateral
Uh,
and also a polygon. Like we're
yes.
narrowing, right? So
Yeah.
you're everything you said and what you just recently said.
So that's kind of what you meant by a hierarchy. So
Yeah.
in the hierarchy, we're kind of narrowing down.
Mm-hmm.
Yeah, and you are
Mm-hmm.
did I ever tell you that my high school math analysis teacher, so it was kind of like pre-calculus. It's called math analysis. I don't know why they called it math analysis. Anyway, what was her name? I think it was Mrs. Barton. Barton? Was that her name? Anyway, she was from the South. And so
Uh-huh.
when she said parallelogram,
Oh.
it was a little different than I'd ever heard before.
Uh-huh.
Parallelogram.
Sounds like parallelogram. Okay.
Parallelogram.
That's awesome.
She was awesome. Anyway, okay, so we have a parallelogram. What else?
Okay. I have 4 right angles.
Ooh.
Tell me
So
what
if
you're
I'm
thinking right now.
yeah, so I pictured a parallelogram with that's kind of skewed,
Uh-huh.
and I
Uh-huh.
just like
Uh-huh.
straightened it up. If you could see my hands, they just straightened up. You said 4 right angles, right?
I did.
So if I have a parallelogram, opposite sides are opposite sides are parallel, and I straighten up those sides so that the angles are right angles, then I have a rectangle.
So
Yeah.
you have a polygon that is a quadrilateral, that is a parallelogram, that is a rectangle.
Yeah, a special parallelogram, a rectangle. Uh-huh.
And I have 4 congruent sides.
Whoa! And I just took that elongated rectangle I was picturing and I squished it so that the sides are all congruent, and now I have a square.
Mm-hmm.
Bam.
Nice job.
All right. Do you want me to name them all? I have a polygon. That's a quadrilateral. That's a parallelogram. That's a rectangle. That's a square.
Nice.
Or a square. Let me say it a different way. A square
Uh-huh.
is a special rectangle, which is a special parallelogram, which is a special quadrilateral, which is a special polygon.
Nice. And I think going both directions is super helpful. How many times do we have kids who say, is it a parallelogram or is it a rectangle? Is it a rectangle or is it a quadrilateral?
Square. Yeah, or rectangle or a square. Yeah.
Yeah. Okay.
Okay,
You want
cool.
you want another one?
I do. That was fun.
Okay. All right. Here we go.
Okay.
I am a closed figure with 3 or more sides.
I'm a polygon.
I have exactly 3 sides.
All right. So now I'm a triangle. I'm a triangle. A triangle that is a polygon.
Uh-huh.
Okay.
I have 1 right angle.
Only 1 right angle, which is good if you're a triangle. So you're a right triangle.
Okay. And none of my sides are congruent.
So you are a scaling right triangle.
Yeah.
Okay, so you're a scaling right triangle that is a special right triangle that is a special triangle that is a special polygon.
Mm-hmm.
Okay, nice.
I have 2 more for you.
Okay, all right.
Riddle 3, sorry. I am a closed figure with 3 or more sides.
Okay, so I'm a polygon.
Mm-hmm. All of my sides are congruent.
I'm a regular polygon.
Nice.
I had to think about that for a second. Okay, sides congruent, regular polygon.
All of my angles are congruent.
So I'm, again, a regular polygon.
Mm-hmm.
Okay.
All 3 of my angles are acute.
Oh, 3 of your angles. So now I know that you're a triangle. And if all 3 angles are acute, you are an acute triangle.
Mm-hmm.
Okay.
Nice. Riddle 4.
Bam. Wait, do you want me to do the hierarchy there?
Oh, yeah, that's good.
Okay, so I'm an acute triangle that is a triangle that is a regular polygon that is a polygon. Or I'm a polygon and a special polygon because all my angles and sides are congruent, so I'm regular. And I have 3 sides, so I'm a triangle, but I'm a special triangle because the angles are all acute, which kind of follows from a regular triangle. Because as soon as I'm a regular triangle, I have to be an equilateral triangle, which also means that the angles are acute.
Yeah.
Yeah. Okay, cool. All right, I'm ready for 4. Bring it on.
I am a closed figure with 3 or more sides.
I'm a polygon.
All of my sides are congruent.
So I'm regular.
All of my angles are also congruent.
Still regular.
All 6 of my angles.
I guess I could also say I'm equiangular.
Mm-hmm.
So I'm equilateral and I'm equiangular.
Mm-hmm.
I could throw those words in there. Sorry, the next one.
All 6 of my angles are obtuse.
6 angles. So I'm a hexagon. I don't know why hex. Why not sexagon? Okay, hexagon.
No.
No, sixagon? Sixagon. It should be a sixagon. Anyway, I'm a hexagon, so I'm six-sided. What did you say about the angles? All my 6 angles
They're
are
obtuse. They're obtuse.
Obtuse.
Yeah.
Would that be true?
Hexagon?
As soon as we knew it was regular, did we know that the angles are obtuse? I think we did.
We just didn't know that it was 6 at that time.
Gotcha. Yep.
Yeah.
Okay, so I'm a hexagon. Yep, a regular
Very
hexagon.
cool.
Yeah.
Okay. So
Nice.
we're taking what you currently know, right? You knew all of these words. You knew some of the relationships. But these riddles are a fantastic way to spiral some of the learning that you've already done.
Okay.
It's a fantastic way to continue the vocabulary, right? So many times in geometry classes, there's a chunk that's like, here's the 2 weeks that we're going to talk geometry. And they are not, those words leave the kids' voices, they leave their heads. And so once you've done some work with geometry, this is a fantastic way to continue that learning. They're super short, right? Just a couple of minutes each. It's a great warm up. It's a great thing that you can do in bits and pieces. I loved having riddles in an area of my classroom. Kids could quiz each other and just put some notes on the back about what the subcategories were. And it continues to build the relationships between the hierarchies.
Nice.
Yeah.
And I think that's a really nice way to take something that is social conventional knowledge, the vocabulary, and give it an opportunity to be kind of practiced in a meaningful, kind of fun, kind of purposeful way. Like we could just say, take this vocabulary, write it down, put the definition in your notebook, put it on a note card, quiz each other. Like that's not only boring, it's not very effective.
Right.
But it is the vocabulary itself, the names. Like I was sort of joking around about the hexagon and sexagon kind of thing. Those we want kids to know those names, and the best way to do that is to practice in context, to have those words come up along with the description, but in a purposeful way, where like what you were just doing, we're sort of narrowing in on this kind of hierarchy in geometry where kids can get even better at the hierarchy. And they can be like, oh yeah, like if I've got a special quadrilateral where the angles are congruent, then I know this about it. Wait, but what's also true? Like maybe if and you didn't give me this one, but if I had a quadrilateral and I said the sides were congruent, bam, then instantly you're sort of over on a rhombus.
Yeah.
And then I could say, now you have a rhombus and I make the angles congruent. Ooh, bam. Now I've straightened up that rhombus into a square. That gives kind of this sense of the hierarchy of how the shapes, like you said before, we're kind of building that hierarchy, and the vocabulary at the same time. We like to do vocabulary when you're sort of begging for it.
Right.
Like when the kids they have this sort of sense of the thing in their head, and now there's a reason to, they're trying to describe it. Kind of like, well, I can't remember exactly what you said. How did you start 3 and 4? I'm a closed-sided.
I'm a closed figure with 3 or more sides.
Yeah. Like you're giving sort of the definition, and we want kids to picture that thing. And then if they can't really come up with the word polygon, then we supply the word polygon. You're like,
right.
Oh, remember it's polygon. Now, it's not like we don't ever want them to come up with it, but this meaningful sort of purposeful practice can be a great way to do that.
Yeah. And really the relationships between the shapes and how they connect to each other is kind of what we want kids to know. How are they characterized so that they're grouped similarly, and what makes them stand out, and why we have a need for a more specialized name.
Mm-hmm.
And I think that's the part that's sometimes tricky for kids, is how can it be this and that? How come it's this, but not that? And so these riddles kind of sort out some of those misconceptions and some of the things that are maybe more challenging, just because it gives them more repetition in a meaningful way.
Yeah. And maybe even in a little bit of a fun way.
Yeah.
Cool.
Absolutely.
All right. That was great. I'm going to put you in charge more often. Woo! Super fun. All right, y'all. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable. Did I just say move? I don't even, did I say movement? Did it sound like movement to me? To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com and keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable. If you missed it, registration is currently open for our Building Powerful Mathematics workshops.
Registration only opens 3 times a year. In these workshops is where you will find and learn all the things that you need to make math more figureoutable. Find details at mathisfigureoutable.com/workshops.
Hey, K-12 educators, we have a workshop for you. Build your numeracy, build your mathematics, learn the teacher moves, equip yourself with the knowledge you need to have students naturally engaged in their learning. No matter what grade level you teach, we have a targeted workshop for you.
And you can find the best workshop for you at mathisfigureoutable.com/workshops.
Let's change the world together and make math more and more figureoutable.